Hello! In this video, we will talk about data audit and how NeoFS takes care of users' object. As we have mentioned before, we use homomorphic hashing to ensure objects' payload consistency. Homomorphic hashing is a special type of algorithms that allow to compute the hash of a composite block from the hashes of the individual blocks. It means if, for example, you have three objects and calculate the hash of their composite contents, you will get the same result as if you just compose hashes of individual objects. When we want to make sure a set of objects is not corrupted, we can store only their composite hash rather than a list of individual hashes. In NeoFS, to reliably store a set of objects, you assign them to a storage group. Storage group is a special structure that has ID and contains a composite homomorphic hash of all objects in the storage group. It doesn't matter if you will have 1 or 1000 objects. Storage group size will remain the same. Storage groups are maintained by inner-ring nodes and used during data audit. Data audit happens at least once every epoch for each storage group. Based on data audit result, inner-ring decides if storage nodes deserve their share of users' deposit for data storage for this epoch. So, we have our three objects and a storage group for them. Let's see how NeoFS will ensure those objects are not corrupted and properly stored. At the first step, inner-ring will ask storage nodes to return the list of objects they store for this storage group. Then, inner-ring asks to provide it a hash of payload for each of objects found by nodes. If the composite hash of all objects is the same as in storage group, it means no objects are lost and they are not corrupted. But what if some nodes are lying? We can find it out by asking to calculate random ranges of some object's payload hosted by a pair of nodes and compare the result. Let's say we want to check if node A or node B lies. We see that there is a circle object which is stored by both of nodes. Inner-ring asks both A and B nodes to calculate homomorphic hashes of ranges in circle object, so that first two ranges of node B would be the first range for node A, and second and third ranges of A will form the third range for B. In the end, by composing and comparing homomorphic hashes of random ranges, we can cross-check if the circle object is really stored on those nodes, because it will be cheaper to store object data than to fake hashing. During data audit, such check will be performed for multiple combinations of nodes and objects, and if some nodes are lying or trying to fake checks, it will be revealed very soon. In such case, node will not get its shares for user's gas deposit for the epoch. Because one node may serve many containers and storage groups simultaneously, the loss may be significant. So the complications of faking data storage and checks in general case just don't worth it. In the end, when all data audit checks are passed, inner-ring will redistribute users' deposit for the epoch between storage nodes.